Hi, so today's video we are going to look at some ratio problems, and I'm just going to go through a couple of those with you. I just want to introduce you to Digby, who's been jumping up behind me while I've been doing the video, so I thought he'd like to say hello. I think he just wants to go back to sleep, so I'll let him go down there and we'll get on with our maths. So I'm just going to do a couple of problems with you just to kind of basically work through how you might use your knowledge of ratio to attack different problems. So I've got two different problems for you with some of the types of things that they seem to be asking at GCSE now to do with ratio. So this is the first one. So we have a recipe for 8 cakes, and the ingredients that we need are 2 ounces of butter, 3 ounces of sugar and 4 ounces of flour. And the question is, how many can we make if these are the ingredients that we've got? And I'm sure that we've all done this before, gone to make some cakes or biscuits or whatever, and you go to the cupboard and find out what ingredients you've actually got. So we want to make as many as we possibly can, we want to maximise that out. So we've got to see how many we can make with those ingredients. Now it might seem quite complicated to begin with, but let's break it down. First of all, we want to look at the ratio of the ingredients. Okay, so if we do butter, so if I call this B for butter, S for sugar and F for flour, then if we have the ratio of butter to sugar to flour, that ratio has to be 2 to 3 to 4. So whatever we do, that's the ratio of the ingredients. We can scale it up, we can scale it down, but that's the ratio that we have to have in order to make these particular cakes. So what I would recommend doing is look for the biggest number, and the biggest number is the 4 here, and then look at the ingredients that you've got. So we've got 16 ounces of flour. So if we look at that, we want to maximise as much as possible. So if I've got 16 ounces of flour, actually 4 goes into 16 quite nicely, so we could change that to 16, and what we've done there is we've actually multiplied that by 4. Now we obviously have to keep all of our ingredients, we need to keep the ratio of the ingredients exactly the same, so we're going to have to do that with all of the ratio, and then check to make sure that we've got enough of these other things here, because if this means that we don't have enough of the other ingredients, then we're going to have to rethink and try something else. So sugar is 3, and if I times that by 4, that gives me 12. Butter was 2 ounces, if I times that by 4 I get 8. Now check back with the ingredients. Well, we've maximised the flour, so that's fine, and we have got enough sugar because we've got 15 ounces, we only need 12, and we have got enough butter because we only need 8, and we've got 14. We can't make any more, and that's important. Although we've got spare of these two, we can't make any more because we've used all the flour. Alright, so we can't do more than that. So that is the answer, that is the ingredients that we need to use. But actually the question was how many cakes can we make? So that's a recipe for 8 cakes. What's this a recipe for? Okay, well, if this was a recipe for 8 cakes, we do exactly the same. We multiply by 4. So 8 times by 4 is 32. So actually it's 32 cakes. So the answer is 32 cakes. Alright, so look for the biggest one, have a mess around with it, try it out. Remember, if that doesn't work, then look for something else, alright? But always check back to make sure you've got enough of every single type of the ingredient, and it is important to write them as ratios so you can see what's happening. Okay, so the last one, on the other side, I've got another one here. This one's a little bit different. So this one talks about counters in a bag. It says there are 6 more red counters than blue in a bag of 24 counters. So it does tell you there are 24 and there are 6 more red than blue. What is the ratio of red to blue counters? Okay, so we're looking, our answer has got to be red to blue. So what I would do straight away is I would write down the relationship between red and blue. So the red counters is equal to the blue counters, remember there are 6 more, plus 6. Okay, so the red counter is equal to the number of blue counters plus 6. So what we can do actually, we don't even need to bring the ratio into it here. We know there are 24 counters. So the number of reds plus the number of blues is actually equal to 24. But we also know that the number of reds is equal to the number of blues plus 6. So we can replace that with the number of blues plus 6 plus blues is equal to 24. And now we just have an equation. If we simplify this, b plus b is 2b plus 6, and that's equal to 24. So 2b plus 6 is 24. I'm going to subtract the 6 from both sides. So that gives me that 2b is 18. And then I'm going to divide by 2. And if I divide by 2, I get 9. Okay, so that means that there are 9 blue counters. So coming back up here, fill in my ratio, that is 9. Now we also know that the number of red counters, there are 6 more than the number of blues. So if there are 9 blue counters, then there must be 15 red counters. And then it's a good check at the end just to make sure we've got our 24. 15 plus 9 is 24, and so that is our answer. Okay, so that's just a little taster of 2 questions to do with ratio that are problem solving. But you'll notice this one actually was algebra, just using algebra and solving an equation, okay, to be able to work it out. And the other question that we did first involves just a bit of trial and error, trying a few things out until you get the answer. Alright? Okay, I hope that's helped and I hope you enjoyed it.